How's it going, guys? Today I'm showing you a little coding project I'm working on in next.js. What this is right here is a little demo web page that's Cyberpunk theme, or at least it's a start of a Cyberpunk theme thing. So I'm not sure if I want to turn this into its own component library and publish it on npm, or I'm just going to make my existing website looks kind of, generic and make this website cyberpunk themed with the existing components I have here. But anyway, I'm calling this thing Robotron. And you can see there's some things going on here. Like I've got this crosshair. This crosshair is inspired by old AutoCAD softwares where you got this big giant crosshair that takes up the entire screen. And as you can see, I have like coordinates that are telling you exactly where the crosshair is. Just some kind of fun extra details. But yeah, this web page, it's meant to reflect what Hollywood's idea of what a computer sees. What a robot sees or what a cyborg sees in those movies like Terminator, RoboCop, Transformers, etc. But yes, back to this crosshair. This crosshair isn't just some giant cursor. Like, this is not some giant cursor of an image that I used CSS to implement. I mean, I did use some CSS, but like, this is just not an image. Let me show you. So I'm using JavaScript to dynamically change the position of the crosshair and change the different dimensions of the crosshair. And the reason why I'm not using, CSS to just have a big giant crosshair is because, to account for, widescreen, like ultra widescreen monitor resolutions, or, just regular resolutions, you would need like a gigantic crosshair that would be like, I don't know, 4,000 by 4,000 pixels wide, and that would just be too much. And so what's actually going on here is as I'm moving the crosshair around, like the lines come originating from the center square are actually resizing. Like these lines are actually divs, and they're being resized by JavaScript depending on where your mouse is currently moving. And so there's no lines hidden that are like off the web page, like hidden going beyond the web page. And so let me show you how I've actually managed to do this. So here's the actual component that is returned. This right here, this div that's reporting the coordinates of where your cursor is, just for fun. We have the left line of the crosshair, the right line, the top line, bottom line, and the center square. And I'm having the styles memoized with the use memo hook just to have better performance. And all the portions of the crosshair are absolute positioned, and they're dynamically updated when you move the cursor around on the screen. JavaScript will adjust that. And whenever you resize a web page, the crosshair dimensions are updated too, mostly. I'm still working on that, but yeah, I'm doing some algebra here. Like the bottom line, the height is the height of the screen minus the cursor's Y position minus 10. And 10 is a little gap for where, the bottom portion of the square is. I'm generally following the same pattern with, the other lines, like the top line, the right line. And right here, I'm limiting the crosshair bounds just to prevent the crosshair from moving off screen. And I'm doing that because this crosshair is created with divs, and if you have a div going off the screen, it's going to create little scroll bars around here. And I don't want that to do that, so I'm limiting the crosshair bounds. So as you can see, up in the top right corner, the maximum Y position, or the lowest Y position, is 10. And so you can't move it lower than 10. Even on the X position, I have the lowest X position being 10. But basically the same thing. We don't want crosshair going off the web page and creating scroll bars. And so if I'm trying to prevent scroll bars, then how am I being able to scroll on this web page? What I'm doing is, well, okay, hold on. So here's where, this is the index page. What I'm doing with the crosshairs, I'm making a crosshairs act as a wrapper. It wraps the main component, and I'm gonna have it so where it wraps the entire web page, including like nav bars, footers, etc. And so it takes, the idea is to have it taken everything on the web page besides itself as a child. And so this main right here, everything inside main, this is considered the children. And I'm taking in children as a prop, and I'm passing it right here inside this div. And I'm setting the height to 100 view height, and on overflow, scroll. So whenever I'm scrolling, the position of the crosshair actually isn't changing. As you can even verify that, because like the coordinates aren't changing when I scroll. Another cool thing I'm doing right here is whenever you hover over a link, the crosshair changes. Like this link I'm hovering over, it goes to google.com. The crosshair changes to a little tiny thicker square. And you can go to Google. And so how I'm doing that is, let's see if I can find it, code. So, okay, here's where it's doing this. So we're trying to find the element from the point where the cursor is. And if there's an element under the cursor and the element under the cursor's tag name is A, an anchor tag, we're going to set onLink to true, which is a use state. And when we're actually drawing the crosshair, that use state changes the box, which is right here. The use memo is recalculated when this onLink is true. That's when it's on an A tag. So here's where we change the styling for when it's on a link. But yeah, I'm pretty happy I was able to do this. So let me show you another portion of this project. This text, there's a little animation that types out whenever you first reload the page. I'm just kind of giving it that little hacker console-y feel. And so how I'm doing this is I made a component called robotyping. We're passing in text through props. And here's the component itself. So this is actually returning text. Wait, hold on. Yeah, it's returning just text so we can keep the semantics of the HTML. Like, this is so if I can reuse this robotyping component on header 1, header 2, a paragraph, etc. And this robotyping, it's using JavaScript for animation. And so what it's doing is that it's a very simple animation. Iterates through the actual text passing props. And it slowly adds original text character by character to be returned here. And while it's doing that, it adds some random characters, like some little glitchy text, like a 1 or a semicolon. And accomplishes this by using sleep. That's how I'm able to generate animation frames, by using this sleep function. And what it does is you pass in the number of milliseconds you want the code to sleep, and it will sleep for that amount of milliseconds. This is what I'm doing right here. It's going to await sleep text length plus 5 minus I. I know this looks kind of weird, but what I'm doing is I'm making the sleep variable so that as more characters are typed, the animation gets faster and faster, just so it looks nicer and more interesting. And now onto the next part of what I'm doing. As you can see here, I have this image of a parrot, and I've applied some image manipulation to it. And this is a very interesting component I've developed. I'm actually taking in the src of the image, and so this is the actual image right here. And so I take in the actual image of the image and I return a modified version of that image. This is This is so you don't have to open Photoshop and like do some monotonous process of like making all your images. You don't have to you don't have to go and manually edit photos in Photoshop to make your images look a certain way. Like this component will actually do it for you. Okay, so we're taking this image right here. And what we do is we first convert this image to grayscale. Why are we converting this image to grayscale? It's because I want to create a Sobel filter of the image. As you can see, I kind of have a Sobel filter visible right here. And these little green edges on the feathers, the eye. And overall, I kind of have this image having a green tint to it. Just give it that cyberpunk hackery feel, you know? And so, okay, so back to how this is working. So we take in the image, we convert it to black and white. We take in how we do that is we get the red, the green, the blue data in each pixel. We average it. And then right here, this is like a one-dimensional array. But, we in color, in computer graphics theory, a grayscale image, each red, green, and blue pixel is going to have the same value. That's what makes it grayscale. And here we have the Sobel kernels, Sobel X kernel, Sobel Y kernel. So we iterate through the original image data, and we apply Sobel X kernel, Sobel Y kernel. Then we get the magnitude of the result. Then we clamp it. We don't want the result being higher than 255 or even lower than 0. And so we're at this point right now where we have a black and white image with the edges pronounced. And we have this now, we generate the green filtered image. We take in the original image data. And what I do is for each channel, besides the alpha channel and the green channel, I take the original image channel value and subtract it from the Sobel image's value. And so if you have like a pixel, the red channel is going to be de-emphasized with the Sobel. It's going to be de-emphasized heavily if that pixel is on an edge in the Sobel filtered image. The same thing happens with the blue channel. We de-emphasize the blue if it's on a Sobel filtered image edge. And the green channel is kind of interesting. And so what I do right here is I just I randomly add bits of green here and there. Kind of gives it a little bit of green noise to it. So after all this is done, we put the image in the canvas and we return it. But yeah, I'm kind of surprised like how quickly I was able to render this image. Like kind of loads instantaneously. Like, I'm not sure how exactly this is going to work with lower powered devices, but I think sometimes we kind of tend to underestimate the performance of modern web browsers and JavaScript. I mean, people have been able to create like N64 video game emulators just with JavaScript, and it runs fine. So yeah, this is my project. Hope you enjoyed it.